And we are normally talking about electrons which are going to be on the outermost, kind of the furthest away from the nucleus. So they're the ones who are the naughty ones, right, who just fly off occasionally. And then they leave behind whatever's left. And what sometimes happens also, that those electrons which left an atom sometimes go and join a different atom. Okay? And here is my bit of terminology which I need to introduce to you. And this terminology is ion. Now, do not get confused between ion, that cast, things which your pans and pots are made out of, right? Or I don't know, bits of your car. This is pronounced the same, ion, but it's got, you can see it's spelled differently. It's completely different meaning. So ion is an atom that either lost or gained an electron or more, right? It could be one electron, could be more than one electron, okay? So here is a bit of a puzzle for you, okay? So if I take an atom, and you remember it's neutral, and one of the electrons is left, is that going to create positive ion, or is it going to create a negative ion? So if I have an electron that is left, right? So it's left an atom. So is that going to create, is this going to create a positive or a negative ion? Okay, so I want you to have a think about it. Okay, so don't give up straight away and say, oh, it's too hard. No, wait, right? Don't give up. Let's think about it together. So I started with neutral atom. One of the electrons disappeared, left, and you've got this information about which charge your electrons and nucleus is. So if one of the electrons left, are you going to be left with a positive ion, or are you going to be left with a negative ion? So what's left behind? Is it going to be positive or negative ion, right? And the answer is it's going to be a positive ion, right? So the correct answer is positive ion if electron left an atom. So why is that? Because if electron which is negative left an atom which was neutral, then what's left behind is going to be too much positivity, okay? And therefore that positivity is going to create positive ion. If, on the other hand, electron joined a different atom, so if electron joined an atom, this is going to create, so I'm just going to draw kind of this arrow, so this is going to result in a negative ion. Okay, so the analogy I sometimes use, right? Let's imagine you have a class, right, of people, and some people are pretty upbeat and pretty positive and saying, oh yeah, it's okay today, it's, there's some sunshine and life is pretty good. And then you have some people who are a little bit more down, a little bit more negative, and saying, oh, this course is really hard, I really don't get it, why did I sign up for it? And so overall, you get a bit of positivity, a bit of negativity. Now imagine that one of the really, really, really negative people who are saying, oh, everything is terrible, why did I come today? I should have just stayed in bed under the blanket. If that person left the room, do you think the mood overall is going to be lifted or not? And I think you will agree that it will be lifted. So you can think about it a bit like that, right? So you remove some of the negativity, and what you're left with is more positivity. right? So your electron left an atom and left more positive picture behind, so it's a positive ion. If you, however, add more negativity to a neutral picture, then you get a negative ion, right? I hope you were able to follow that explanation, because it is fairly tricky, right? So now I'm going to give you some examples of ions. So let's say you've got something like this, H+. So let's have a think about it together. So first of all, I know that H is hydrogen, and I can see plus sign here. So I know it's not just a hydrogen, I know it's not just a neutral atom, but that it's an ion. So I know from this symbol that this is hydrogen, Gen ion. And I know from this plus sign that it's a positive ion, so positive ion. And finally, I also know that it's lost an electron, right? It lost one electron because there's just one plus there. Okay, so it's lost one electron, right? So that negative electron left atom of hydrogen, and what's left behind is this positive ion. So I'd like you to do the same thing, but this time with several other ions, which I'm going to be writing down. So can you write, full explanation? So which kind of ion it is, positive or negative, or whether it's lost or gained, and how many electrons, okay? So this is going to be a bit of a little task for you. So let's do this one. Again, I will expect you to write down the full explanation. Let's do something like this, okay? And let's do, oh wait, did wrong thing, so it should be minus. Okay, so instead of re-recording the whole video, if you don't mind, I'm just going to scribble out and do the right one. And let's do this one, okay? Right, so that's where you will have to pause the video and then write down this kind of full explanation, which kind of ion, positive, negative, lost or gained, and how many. Now, we're going to check it next time, but for now I'm also going to add a little bit of complexity here, because sometimes you do get ions where it's not just one atom, but it's a combination of atoms which lost and sometimes gained electrons. So you can get something like this, for example, right? We've got oxygen and hydrogen connected together, but all together they gained an electron, and that would be something called hydroxyl ion. Hydroxyl ion. Okay, so ions are not necessarily going to be just single atoms. You might have this kind of a little bit more complex picture. Or, for example, another type of ion you might come across, something like this. Okay, so that's a negative sign. Let me just get rid of that, otherwise it looks like minus, and it's not. It's just I'm saying that's what it's called. So this is bicarbonate ion. Okay, so you can see that sometimes ions can be a bit more complicated than just atoms which lost or gained electron. But anyway, your job is to still deal with those ions which I named earlier. Okay, so you remember all of this was to do with level of organization number 7, atoms, but you might also be able to remember that we left out number 6, right, molecules. So what am I going to tell you about molecules? Well, molecules, just to simplify it a bit, the actual definition a little bit more complex, but just for our purposes it'll do. So molecules are 2 or more atoms bonded. By bonded I mean chemically bonded together. Okay, so let's give you an example. For example, if I write letter O, capital O, that means it's an atom of oxygen, right? You remember we kind of named it earlier, right? And that's section 7, there it is, right? So that's an atom of oxygen. But if I write, a famous mobile network, right, O2, this is no longer atom of oxygen, this is a molecule of oxygen. Right? And how do I know it's a molecule of oxygen? Well, I've got two. That means I've got two atoms of oxygen bonded together, which makes it into a molecule. So I can no longer call it an atom. Right. So a few more examples of molecules and atoms. So, for example, this is an atom of hydrogen. Came across it before. And again, same thing. If I write it as H2, then this will be a molecule of hydrogen. Okay, hydrogen. So what we're breathing, right, what's around you is not actually atoms of oxygen. What you're breathing is molecules of oxygen, because that's what you find in the air around you. And the same kind of goes for hydrogen, right? So you're not going to have atoms of hydrogen flying around. Most of it is going to be bonded in the form of molecules of hydrogen. So a few more examples. What about this? Is that an atom or a molecule? So I hope you will be able to recognize it's a molecule, and I'm also hoping that you be able to tell me what this molecule is. So this is a molecule of water, right? And my next question is, well, how many atoms does it contain? How many atoms, right? So let's think about it together. So I've got H2, so that 2 belongs to hydrogen, right? So it tells you there are 2 atoms of hydrogen and there is only 1 atom of oxygen, because you have no number here, so that assumes 1, okay? So 1 oxygen, 2 hydrogens, so it means 3 atoms bonded together. Bonded, right? So 2 hydrogens and 1 oxygen, okay? One more example. This one, what's that? CO2, okay? I hope you, again, something you could name. So this is molecule of carbon dioxide. Again, how many atoms are there, right? CO2. So C doesn't have any number, straight after it, so it means it's just one of them. Oxygen has got 2, so therefore 1 carbon, 2 oxygens give you 3 atoms altogether in that molecule, right? So molecule of carbon dioxide, hence di. Di means 2. 2 oxides, 1 carbon, 2 oxides. That's where the name comes from. Now, here's another one, right? What about CO, right? Very, very similar, isn't it? So all I've changed is I dropped that 2 after the oxygen, but then now it's no longer a molecule of carbon dioxide. This is a molecule, got lost in all the, let me try again, molecule, there you go. So molecule of carbon, still have carbon, but this time it's carbon monoxide. Mono means 1, mono. Side, right? So 1 oxygen and 1 carbon monoxide. So if you breathe that, well, nothing particularly bad is going to happen to you as long as you're also breathing some oxygen, right? So this is something you're breathing out, actually. So no big deal. But if you breathe some carbon monoxide in, that's not going to be good news, because you can potentially die from carbon monoxide poisoning. So even though the only difference is that 1 atom of oxygen which is missing, but in terms of the effects on the body, it can be very, very different, very drastic. Okay, so this is okay for you, in small leash doses. This is really bad news, right? Carbon monoxide can be extremely toxic because it bonds to your red blood cells and doesn't get dropped off. Okay, so then there is less space for the oxygen to get connected to your red blood cells, and that's why you essentially your body is going to shut down because of lack of oxygen getting delivered to your cells. And one last example, this time the molecule is going to be slightly bigger, so C6 H12O6, and I suggest you try to remember this one. So C6H12O6, and this is a molecule of, and I'm really hopeful some of you will be able to name this term. So it's a molecule of glucose, right? The really important molecule. So again, I know it's a molecule because I have a whole bunch of atoms bonded together here, and I'd like you to count how many atoms are there in a molecule of glucose. Okay, so that's another little puzzle, another little bit of homework for you to complete. Okay. So that's what kind of will complete this topic of levels of organization. So we covered, we've gone from human body and kept zooming in and zooming in and zooming in into molecules and further into atoms and further into even talking about sort of ions, right? And the reason why I talked, going back all the way to kind of the smallest unit which we considered, the reason why we talked about atoms and ions is because your body uses ions for processes such as muscular contraction, nervous impulses, and these are all going to be discussed as a part of the course. So you do need to be aware of these terms and at least have a rough understanding of what it means. Okay, so that's the end of this video. Thank you very much.